So let's check out the rest of the examples from our 11C notes. So again, a few more examples on using different similarity relationships. So looking back at your organizer, let's look at example 6 next. So cylinder A and cylinder B are similar. Cylinder A has a diameter of 24 feet and cylinder B has a diameter of 30 feet. So they're just giving us lengths of something in our figure. So they're talking about the scale factor. So let's go ahead and write our relationship for that and see where that gets us so far. So again, I'm going to keep A on top, B on bottom, just to keep my order straight. So we're going to have 24 over 30. Wait a second, can I simplify that down at all? Oh yeah, absolutely. So if I simplify that down, well, 24 and 30, they both have a common 6 that I can divide out. So if I divide 6 out of the top, then that's going to give me a 4. 6 divided out of the bottom is a 5. And again, you could always do that math enter trick on your TI calculator, or just hit the fraction button on the Desmos calculator and it should give you your reduced version. So what do they want us to know on here though? So we went through, we read the first half of it. Last sentence says, what is the ratio of the volume of cylinder A to cylinder B? So again, volume, if we're thinking about the columns where we were playing around with the numbers, scale factors in the first column, surface areas in the second column. So we have to jump all the way to the third column. So volumes. But what kind of units do we always have on volumes? Now they're always cubed units. So that's what we need to do to our values. We need to cube them. So we're going to take 4 and cube it, and we're going to take 5 and cube it. Simplify that out. There's our answer. Alrighty, so 4 cubed gives us, I got to check that one. So 4 cubed, that gives me 64. 5 cubed, I believe, is 125. Nope, 5 raised to the 3. Yep, 125. So that's our relationship between cylinder A and cylinder B. And again, we didn't need to know, or yes, they gave us the diameter, but notice I didn't actually calculate any volumes on here. All I did was use the relationship that they gave me, rather than going kind of brute force, finding my formula and figuring out those values and having to do those equations multiple times. All right, let's look at 3 more problems where they give us actual measures and we've got to solve for the size of a missing object. So here we go, example 8. Excuse me, example, I misnumbered those. I'm sorry. So example 9. Alrighty, the ratio of the diameters of 2 similar cylinders is 3 to 5. If the surface area of the smaller cylinder is 378, find the surface area of the larger cylinder. Okay, so they gave us ratio of the diameters. They gave us the length. So they basically gave us the scale factor relationship. And they said that that was 3 compared to 5. Okay, then in the second sentence, they're talking about surface areas. So that means I know I'm going to go straight to the next column. And every time I'm doing a surface area, we're multiplying how many dimensions? So I know I'm going to have to square my numbers to figure out my relationship. So 3 squared compared to 5 squared. Well, 3 squared is 9, 5 squared is 25. So this is really the relationship I'm going to have to use for my final answer. However, then they started giving me more measures. So they said if the surface area of the smaller cylinder is 378, find the surface area of the larger cylinder. So again, let me change my color. So the smaller cylinder is 378. So if I take my relationship 9 compared to 25 and I start making a proportion, where should I put that 378? Well, yeah, it's the smaller value. The 9 is smaller in the original fraction. So we're going to go ahead and put 378 on the top in the numerator. And I'm going to put an X in the denominator to know what I need to solve for. And so let's just cross multiply and solve out for X. Alrighty, so 9 times X will give us 25 times 378. And definitely need the calculator on that one, unless you want to do your math out by hand, which is never a bad idea. It's really good practice. All right, then divide both sides by 9. All righty, so X equals 1050 But this is an area volume problem, so if they gave us units, which they did, the smaller cylinder was 378 inches squared. So the bigger cylinder is 1050 inches squared. So larger cylinder. Alrighty, 2 more examples. Here we go. Number 11, if the prisms are similar, find the value of x. So instead of explaining it, they gave us a picture, and these look like some pretty funky prisms. But I don't think we need to do a whole lot of calculations on these. We just need to use our relationships. So the first thing is they gave us a volume and a volume. And then they gave us 2 corresponding sides. So they gave us a 20 and a 20. So we could reword this if we want to, saying the volume of 2 similar prisms has the relationship 840 to 105. Find the missing length of the smaller pyramid if the corresponding length on the larger is 20. So again, the only thing they gave us 2 pieces of info for was our volume. That's like going to the 3rd column of the chart. So they gave us volume was 840 compared to 105. Yeah, we should definitely try to reduce this down. So again, math enter on your graphing calculator, or do the division and hit the little fraction button on Desmos. And actually, I get out 8 when I divide that. Now, I still want to have this in a fraction form. So I'm going to write it as 8 over 1. So I need to take that now. And are they asking us to solve for an area or a length? Yeah, we have a length. We have to solve for x. So I'm going to take it not back to the surface area, but all the way back to our scale factors. And so what do I have to do to go from volume, which was cubed, to scale factor, which isn't? Take the cube root of both terms. So cube root of 8 and cube root of 1. Again, you can do this on the either calculator, or think about what do you multiply by itself 3 times to make each number. Well, for 8, that's a 2. And for 1, that's just 1. Wait a second, that's a really nice relationship. So let's think about this. So we know now that the relationship between the lengths on the prisms is just 2 to 1. Okay, so well, if 2, let me change my color. So if 2 to 1 is our relationship, and that's the bigger, should go with the 2. Let's see, 20 comes from the bigger one, and x comes from the smaller one. We could do this actually without a whole lot of math. What do you think x needs to be? Yeah, it's just going to be half the larger one, which means it's going to be 10, but we could do the math. If I cross multiply, I'll get a 2x equals 20, and divide both sides by 2, I still get that 10. Make sure to include your units. This one was talking about centimeters. So that's the smaller side. Alrighty, example 12. Here we go. Cone A and cone B are similar. The surface area of cone A is 108. The surface area of cone B is 147. If the volume of cone B is, okay, so before I even finish reading, the first set of info they give us is surface areas, and they want to know volumes. We can't go directly from surface area to volume. So we got to go surface area first, figure out what's our scale factor from that, and then take that and take it all the way over to volume, and then we can do the problem. Okay, so surface area is what they started with. Surface area is always squared. They said our relationship or our values were 108 compared to 147. Okay, what should we do first? Now let's see if we can reduce that, because 108 doesn't look like a perfect square. So let's see, 108 divided by 147 gives me kind of a funky fraction, but then if I convert it back over to a fraction, gives me my reduced version, which is 36 over 49. Do those numbers look familiar? Yeah, so first step, take it back to your scale factor, which means what do we have to do to the 36 and the 49 if surface area was squared and scale factor isn't? Take the square root of both. So square root of 36 and square root of 9, those should look, excuse me, 49. Those should look familiar. Yep, square root of 36 is 6. Square root of 49 is 7. So now what do we do to turn that into our volume relationship? Yep, take that number now, and we're going to cube it to make volume. So this is kind of our second step that we're doing. Okay. So first step, second step. So we're going to take 6 over 7, and we are going to cube those numbers. And again, might need to check that on your calculator. So 6 raised to the third power is 216. 7 raised to the third power, 343. Okay, always a good thing to go back, double check your problem, make sure you understand what it's asking. So cone A and cone B are similar. Okay. The surface area of cone A is 108. Surface area of cone B is 147. We dealt with that. If the volume of cone B is 857.5 millimeters cubed, find the volume of cone A. And since they're asking us to solve for a volume, we need the volume relationship. That's what we're going to use now to write a proportion. So if our proportion starts with 216 over 343, they told us that the volume of cone B, which we've been putting on the bottom of the fraction, if that's 857.5, where do we put that in our other fraction? Yep, right on the bottom. So 857.5 in the numerator, then there's the x, which is what we're trying to solve for. Okay, cross multiply and solve. So we have 343x, and we have 216 times 857.5. That's not a pretty number. Times 857.5 gives me a very large number of 185,220. Wow, 185,000. That's pretty big. But keep in mind, what do we have to divide out to solve for the x? And we've got to divide out that 343. So we're dividing a large number by another large number. This actually doesn't come out too bad. It comes out to 540, excuse me, 540, not 545. Make sure you have the correct units on there. So the original that they were giving us, the other figure had millimeters cubed. And so let's think of this. Well, if we were solving for the value that was on the top of the fraction, that's where we're putting the smaller value. We got an answer that was smaller than 857.5. So our answer is consistent with what we should be getting. So again, that's going to be the volume of cone A. As always, let me know if you have any questions on these, but absolutely make sure you're writing down all your work and kind of doing a mini chart with your relationships before you decide which one to use. Let me know if you have questions.